but I know it's there. There's a shore in the middle of the storm. We could rest upon. I don't see it yet.
Hello Smars fans, how are you doing? I hope you're having a good evening. So, do you want to build your own robot? Don't know where to start, what you'll need or how to do it? Then you're in the right place. And if you stick around, you can help me pick what projects we'll be working on next. So, let me get over to... Great. So, yes, today's episode is all about wiring up the Smars and getting it up and running from an electrical and component point of view. So, let me get over to the slides. Get to, oops, not that one. We want the, oops, pressing the wrong button here. Let me try that again. We need the screen sharing button. There we go. Okay, so today we'll be wiring up the electronics, as I said, and what that involves is looking at the motor shield, plugging that into the Arduino. We'll be wiring up the rangefinder. That's these little components that look like this. It's like the face of the Smars. We'll be connecting up the motors, which we installed last week in the assembling video. We're connecting up the battery, our 9-volt battery. We'll be running over what the pinouts are for the Arduino and the motor shields, and there's a few variances between motor shields. And we'll be looking at how we can plug in some additional options like line follow, Bluetooth, gyros, that kind of thing as well. So, if you're following along this week, these are the components that you'll need to build along with us. So you need the assembled robot that we built so far. You'll need the rangefinder module that I've just shown you. You'll need some DuPont cables. I think I've got some here I can show you. So DuPont cables, if I just go full screen a second, are these cables that have the sort of square ends, or on the other end they might have the male connector. So that's the female end, that's the male end. And depending on what your shield is or what you're plugging it from and to, you might need different variations of them. So just looking around, I've got there's 3 different types. You've got male to male, female to female, and male to female. So that's what we need for that. Let's get back to our keynote. So you'll need a battery connector as well. I've got a bag full of them knocking around somewhere here too. There we go. So you can usually buy these on Amazon, and they're just the 9-volt battery connectors. Need some 9-volt batteries themselves. I bought a job lot of these from Amazon. Just looking in my top drawer here because I have a my project drawer until I move into my new office, my new live stream office. So I've got some regular 9-volt batteries there and the motor shield itself. And as I said, there's a whole variety of them and we'll be looking at some of them today as well. So how does all this plug together then? So the brains of the operation is our Arduino. We have an Arduino. I've got a few of them hanging around here. Oops, let's not move that one. Got some live Smars sat up on my desk here. There we go. Stay still. Behave. We'll get to that in a minute. So if we just pull apart this an Arduino clone here, we can have a look and see what we are working with. So I've got my Arduino clone here. There we go. So that one is from Elegoo. Is that? How do I pronounce that? Elegoo. But it's very similar to the Arduino Uno, the version 3, which is very popular. That's the one I've got. So yes, the pins on the outside, these header pins, these black pins here, that's where our connectors can connect into and talk to the Arduino. And you can see on screen there we've got all these different pins that mean different things. So we've got some for voltages, 5 volts and 3.3. We have some for analog, which is if we want to read in like waveforms that change very subtly, you know, like potentiometers and things like that, reading in servos and so on. Then we have digital pins. So the ones on the the sort of longer side on this side here, these are all the digital pins, so we can use them to turn things on or off, or give them very discrete values between 0 and 255, 1 byte's worth typically. And we can do things like serial communication, sort of sending and receiving data as well. So that's what an Arduino looks like. But really, what an Arduino actually is, if I go over to our SMARSCAM, these little chips here that I've got, you can see that chip there, that is an ATmega chip, ATmega 328P I think it's called, and that's what they look like. If you were to look at it a bit further up, let me just go to screen share again. That's what they look like as a pinout of their own. So they don't match up with the Arduino pinouts, but really that's what's going on behind the scenes. There is all these different pins that mean specific things, and we could build our own Arduino if we wanted to. So what I was looking at just before the start of this was putting together a little breadboard here that's got an Arduino, well, it's got an ATmega chip on it. It has the crystal, which is this little silver thing here, which is a 16 megahertz crystal, and then there are two nanofarad, 22 nanofarad capacitors there, ceramic capacitors, that just sit in between the crystal and ground. And what we do there, if you look on screen again now, as I put it back to the keynote there, pins 9 and 10, the ones that I've got the XTAL1, XTAL2 are the crystal. That's what XTAL means in this case. So if we have our crystal sat across them with the 22 nanofarad capacitors to ground, that will mean that our chip can run at 60 megahertz, so it's running pretty quickly. If we don't have the crystal in place, I think it defaults to something like 4 megahertz, possibly 1 megahertz, depends on the chip. But it does run without any of those, so it can just run on its own. But we can plug things directly into this. But the idea of an Arduino is it's a standard shape. The headers are in a very standard configuration, so you can know what to expect from a positioning point of view. Behave, you two. They've got bones this evening, so they're chewing on bones. And what this means is we can plug things in. Manufacturers can make things like these motor shields, and it means we can fit them in a very specific place. So, and everybody knows what the pins mean. So that's why this has been such a popular configuration for the Arduino. So the rangefinder module, let's get onto that piece before we plug that in. So we looked at this in one of our earlier videos, which was about the rangefinder itself and how it works. So what it does is essentially pings out on the Echo, I think it's the Echo one, and then it receives back on the trigger. And it can do that, it calculates using the speed of sound to the echo coming back from the object that it's bouncing off, and therefore it can figure out how far away that object actually is, and it's pretty accurate. It's within, you can see there, 1,000th of a centimetre, so it's quite accurate. So from a component point of view, there is a ground, there is a voltage in. I think these are 5 volts. They're certainly tolerant of 5 volts when I use them. And we have the trigger and the echo pin as well, which is how this thing works. So that is what they look like from an electrical point of view. We will wire up in a second. I'll just go through a few more differences on these motor shields, and then we'll get to actually wiring the thing up. So the motor shield that was originally brought out, I'm just looking across there. There it is. I just need to get it without. There we go. Get it without moving one of my Arduinos. Smaz, he's thinking about moving. So this one is one of the original, or I should say authentic, genuine, original Arduino branded motor shields. And what they've got on here is the top two. I'll just go full screen so you can see me a second. So I'm just looking at this one. So what we have here, we have 2 in, 2 out, and then there's 2 other ones which I've never used before. It says transmit in, transmit out. So I think they're serial in and out as well. I've never used these, but I guess these are designed for some project that Arduino themselves may have created. The thing we're really interested in is the bottom here. These are where we put our motors in. So there'll be the ones on this side here. These are the ground and the voltage in, and that can be 9 volts, 12 volts, I think. And then we have motor A and motor B. So we go back to our screen share. We can see there we've got the power. We have motor A and motor B. The left motor, as we look at our SMARS, top down facing forwards, the left hand motor is motor B and the right hand motor is motor A. Now the thing that I'm interested in there is what pins are these, because when we write our code we need to know which pins do we need to speak to make the motors work. And there is usually a pair of pins, because one sets the direction that the motor is going in and one will set the speed at which the motor is going at. So they usually come in pairs. So that's the official one, and we'll look at the pinouts themselves in a minute. Then we have the one that I quite like, I've got quite a few of these, is the Funduino. So if I just go to the SMARS cam a second. So this is the Funduino one. I think it says it just in the corner. If I just get that on screen there. Well, Fujimoto. I always call it Funduino. Fujimoto. The reason I like these is they have a buzzer as well as dedicated pins. These yellow pins here are dedicated for the rangefinder, so it makes it very easy for us to plug things in and to do some fun things with buzzers as well as having motor. Oops.
I'm having trouble hearing you.
Motor A, motor B, and the power in as well. That's my Apple Watch just chipping in there. And then we have a third one, which I haven't done a screen diagram for, but I'll just show you now on the screen there. And this is another variant, and this has actually got 4 motors, so it's got A, B, C, and D, and just where my thumb is there is the power in. So this is another one. This is from, if I turn it that way around we can see it a bit better, MH Electronics. And they all run off the same kind of chip. You may even see some of this configuration. Again, we've got motor A, motor B, we've got power in, and we've got some header pins just at the back there for controlling the speed of the motors A and B. So there's quite a few different variances of motor shields. We carry on showing you other motor shields that we can use. There's one here from Adafruit, which is their Cricket, and this is for a microbit. So I have a microbit just running a little program here. It's just saying hello world. That's also running in another one. That's a Kitronix motor shield. So we've got motor A, B, C, and D. What else have we got there? We've got an in as well on the other side, and we've got the power as well, which is running there. So you can see that's running a little piece of code on the actual microbit. And it's the same with the Cricket. You can put that in there. We have power in, we have motor A, motor B. And then there are some other variances as well. You might see this one for the Node MCU or ESP32 chip, I think that is. Again, that's got motor A, motor B, and voltage in as well. And it's got a whole lot of header pins as well for things like servos. So I'm looking forward to using that one in one of our SMARS robots as well. So that's a few different motor shields that we have. Just trying to see if there's any other ones that we might have covered off. And the only thing that seems to differ across them is that they don't have a standard set of pins for motors A and B, which means that we need to be aware of what the pinouts are when we're writing our code. So these Fujimoto ones, not Funduino, Fujimoto ones, they have a standard set of pins which I've got in a table in a second. So we can see the buzzer, for example, is on pin 4. The trigger and the echo, which are wired into them yellow headers there. The trigger is on 7, the echo is on 8, and the ones either side of that, the very bottom one with the little plus symbol is 5 volts, and the one on the very top there is the G, which is ground. And then we have, this is how we wire the whole thing up. So we will go across, oh, I'm telling you this, and I've not got my screen share on. Let me just go back to that so you can see what I'm doing there. So yeah, I'll just repeat that just to make sure we've got that. So on the Fujimoto board there, we can see we have the little yellow header pins. So the buzzer is on pin 4. The trigger is on pin 7, which is this little T one here. The echo is on 8, which is the R there. I think they call it like a receiver. and then the G is the ground, and the plus is the power, which is 5 volts. Thanks for that, Sammy, just saying screen. Yes, I realised as I was speaking there. Okay, so let me just go back to, let's go to the next slide again. So this is the wiring diagram. So I'm just using the Fujimoto board, and we can see that we've got the rangefinder at the top. That's plugged into we've got the black wire going to the ground, the red wire going to the power, and we have the green wire going to the trigger and the blue wire going to the echo. We've got the 9-volt battery connected up to the ground and the power, and we have the motors A and motors B plugged into the bottom there as well. So we will try and give that a go. So let me move my microphone a bit closer to where I'm working, just so that you can hear me while I'm working. And let me go back to the Smars Cam. So what I can do on this, that annoying 1x thing there, I'm just trying a different app out to do the overhead camera. When I've got the studio set up for real, I'll probably get a better quality camera in there, but for now we're just using my iPhone, and it's not a free app, in fact, it's a paid app that enables me to just use it as a webcam. So here is the Arduino. If I go to 2x zoom there, we can get a bit of a better shot there. So that's the Arduino as we left it last week. So we've got our battery plugged in, we've got our motors soldered in place with the wires coming through the middles of the motor holders, and we have the battery wire just dangling off here as well. So the first thing I usually do when I'm working with these, I'll make all the wires face the back of the Arduino. So we know which way is the back and the front. The front has this little lip on it here. You can just see there's like a little notch there, and that's where when the Arduino slides in, it slides up to that point. So what I usually do is have the wires push down, coming out the back of the Arduino. So what we'll first all do is we will get our Arduino. Just thinking which one I should use. Let's go for this one. And what I will do is I'll push this, I'll slide it into place into the slots there. Let me just make sure you've got a good view of that. So that's going to slide into place there, and you can see the notches there. It slides it up to there, and the wires are just coming out the back there. So then I'll position the wires into place. So I've got my battery, they're going to come to that side, and their motors are going to be there. So let's get our motor shield. So there it is, and again this is just going to slot into place there. Oops, like so. There we go, nice firm all around on each side. So now what we'll do is we'll wire up the motors. I've got a little screwdriver here. There's little screws that we can tighten the contacts with, so we'll just do that on here. So that's going to go into there. Now if I don't get this right first time round, we can just, if I've not got the direction correct, we'll just reverse them, but I think this is correct. Let's give this a try. And what I've also done is I've preloaded some code into this Arduino as well. And what this code is going to do is it's going to measure the distance so we can test out that the rangefinder is working, and it's going to either move this Mars backwards or forwards depending on what the distance is. So it's going to try and keep it between 5 and 10 centimeters. So we're going to put the ground in now. Let's see what happens. So what it should try and do is go forwards until it gets a range. Now we haven't connected up the rangefinder yet, so what that should tell us is, have we got the motors in the right direction? So it's a bit stubborn there. Let's just try that again. Sure, this is very exciting for you all, watching me screw some screws in. There we go, and then this is where it jumps out of my hand. Let's come out again. That's a pain. So let's see, is it going to do anything? Oh, that's running the blink code, I can see that. So which Arduino did I use before? This one hasn't got the code loaded in it, so I want to take that one out. That's a pain in the bum. Let me just work on one of these next to it. That noise you could hear is one of the Arduinos that I've got, one of the Smiles that's already set up, ready to go. So what I'm doing now is I'm just putting in another Arduino there that I think has got the correct code in it. I just wanted to be able to run the code so that we know, oops, that's not even the right Arduino. Autoshield, let me just do this again. The joys of going live. There we go. Okay. Let's try that again. I'm just going to try it with one set of motors first, just to make sure I've got that right in place. I was watching a video from the 8-Bit Guy. I don't know if any of you guys watch the 8-Bit Guy, and he got some very antique, rare computers from a computer fair and utterly destroyed the thing. He shorted out the power supply with a paper clip, grinded off some security what do you call them? Security screws, which he could have easily got a screw connector thing from, is it Lowe's? I don't know what you guys have in the US or elsewhere for, you know, home parts, screwdrivers and things like that. Anyway, utterly destroyed this computer. And the comment section of his computer is like, you know, this is outrageous. How dare you destroy, you know, some heritage? And I'm just trying to get these header pins in here. So yeah, it made for an interesting video, but I was wondering, did he do this on purpose, or was he just being a bit clumsy? Right, I'm just going to try this again. This refused to connect in properly last time. Right, so this is one of the flaws I always think with Smiles. We need to have a switch on these things, because as soon as you power them up, that's better. Right, that's good. So what that's telling me is that the code is the right code that's being run, and that I need to reverse some of the motors because they're going in opposite directions there, and they should be creeping forward. That one's correct, that one's not correct. So I think, yeah, I've got them opposites there. So if I unscrew that, I don't know if you can see that there, it's one of them is running in the wrong orientation. So let's do like that. There we go. That's better. Okay. Right, so that's moving forwards currently. So what we need to do now is get our rangefinder, which I've just got here. So that's going to just slot into place there. And this is where we need our DuPont connectors. So because I'm using the Funduino or Fundumoto board, that has the male pins, so I need a female header, and it has the male pins on the rangefinder as well. So I need a a female to female type cable. So you can see it's got the squares on both ends there. So what I've decided to do on this one, just to make it a bit easier to, there we go, I'll just plug those in there. So what I'm going to do, I'll just take this out a second. So I'm going to use the orientation of the white cable is going to be our power cable, the black cable is going to be our ground, and the blue and the green are going to be the trigger and the echo. So on here I can see on the very back of there, I don't know if you can see it there, just underneath this white thing, there are some, it's not quite in focus that, you can see that it basically has the echo, ground, plus minus. So the first one, I'll just do this so you can see it, push them all in at the same time. So the one on that side, which is white, is going to be our voltage in, the black one is our ground. We have the green on the trigger and the blue on the echo. Right, so let's push this into place. And let's get this wide up. So we said our blue is our echo, didn't we? So that goes next. So we need to do this, and then our black bit needs to go next. And trying out there just to see. I think actually the motors are back to front, so I'm going to switch them over. Get in. Okay, nearly done. So this code is what I call the follow me code. And what the follow me code does is it will go forwards until it detects an object less than 5 centimeters in front of it, at which point it'll reverse direction, and then it'll keep going backwards until it detects the object is further than 10 centimeters away. Right. So there we go. So what it will do is it'll go forwards. I think that side's a little bit sticky. So it'll go forwards until it detects something. So if I move this, put this back on, and one there, and we move this guy quite far back. Yeah, he's got a bit of a sticky side on that side. That motor's he's going to keep going forwards until he detects something, and then he's going to stop. Now these two next to him have also got the same code loaded. So if I move this one back here, you can see it's going to keep going forward until it finds something. If I put my hand in front of it, it'll back up. You see that? It's backing up. If I let go, it'll go forward. So in theory, we could get a chain of these all together, and they could all follow each other until the first one finds an object or backs it up. There we go. Got 3 smiles. All going crazy. My little pooch does not like these. Right, let me just move you back there a minute. There we go. There we go. I was just moving them about a bit again. Okay. So that's how we wire up the SMARS. That's what we need to do there. So I talked about the pinouts before being different between a couple of the boards. What I will do, I'll do some experimentation with this board as well, which is that MH Electronics one, because that seems to be quite a popular one. You always see it with those 3 pins in the middle and 3 chips in the middle. So what I will do is I'll experiment with that one, figure out what the pinouts are, and add that to this table as well. And I'll put a link in the description to this table so you can find it as well. I'll create like a Google Doc or something like that so that you can find it. So as you can see, the Fujimoto has an echo, trigger and a buzzer, whereas the standard Arduino board does not. So that Motor Shield doesn't have the buzzer, the echo or the trigger. And it has a slightly different motor A. For some reason they decided to put that on pin 3, whereas on the Fujimoto it's on pin 10. Everything else is the same. So why they decided to do that, I don't know. If I was manufacturing it, I would have looked and thought, let's just keep it standard and follow the. It might have been an intellectual property thing, maybe they had to make it different. Anyway. So the next thing I thought we could add into this as well would be a Bluetooth control. So if you want to be able to remotely control your SMARS, and we did do a video on this, so I'll put a link for people who are watching this on replay. I'll put one of those little card things up to that video which we did about Bluetooth and remote control. But simply what we need to do there is just plug in the transmit and receive the TX and RX from the Bluetooth module. I usually use pin 2 and 3 on the Arduino, and I will create a software serial in the code to connect to those pins. I will never use pin 0 and pin 1, which are, I would say, reserved for the Arduino's serial, and it doesn't work well if you try and use both of those the same time. You just end up thinking that the Bluetooth module isn't working. And the other thing I discovered as well was the Bluetooth module, the HC09 is probably, or 8 or 9 is probably one of the better ones to get, because that works with iOS as well as Android. You can get a HC05, they are HC5 or HC06, and they're very cheap, but they only work with Android, and it's to do with some kind of licensing thing, I believe, with Apple, and also to do with the low power mode. I think with the very original Apple iPhone didn't have Bluetooth 4 on it, and Bluetooth 4 is where they get this low power mode. And because of that, if you tried to connect like a Garmin or a TomTom GPS to your original iPhone, the battery would go flat in like a matter of, minutes. It was really drained it. So Bluetooth was originally quite a high power thing, whereas now Bluetooth 4 onwards, 4.1 is it, makes it very, very low power. So these modules, the HC08s and HC09s, I believe, are all low power. And we did cover that on the Bluetooth video that we did. We went through all those. So from a wiring point of view, exactly the same configuration as we've just built. So exactly the same configuration as we've just wired up here. But we add to that Bluetooth module, and we just plug it into pins 2 and 3 for the RX and TX. Like I said, if you want to see how to do that, we have a video on that too. Okay, so here's the question of the week. What should we build next? So I'm aware I've been working on pretty standard formulaic SMARs. I have built the quad. I do think we should do a video on building the quad, just like we have done with this standard SMARs. But as a sort of bonus video for this series, I'd like you to choose what we work on next. So do we do the forklift modification, which looks very interesting? The shovel looks quite boring, to be honest. I think that's a very easy print. I'll probably print that one anyway. The SMARS Zero, I believe, is like a completely different interior. Has a Raspberry Pi Zero. I've got quite a few of them knocking about, so that'd be easy for me to do. I do have the ESP32 camera module as well, so I know Kev Thomas was working on a SMARS version 4 that has this little module built in, so this can also be the brains of the SMARS, as well as being a camera for the front that we can stream or do whatever we like with. There's the let me just go back to the slides there again. So yeah, that's the SMARS Zero. There's the version 4 SMARS. So that's quite a different design inside. I know the wheels, it has a motor on each wheel now rather than every other wheel. So it's much more powerful. The wheels are a more interesting design as well, I believe. So there's the version 4, and there's also the version 4 with the shovel as well. That looks very appealing to me. As a small boy, I'm like, that's what I want to build. But the claw looks quite interesting as well, so you can actually grab things, and the pen holder. I'm not sure I could draw anything very good with the pen holder, but might do that one. So they all work. The claw, the shovel, and the pen holder, I believe, just use a single servo, and I have got a bag of servos in my drawer beneath me, so that would be, again, a very easy one to do. So what do you think we should work on next is my question. So put in the comments if you're watching live. If you're watching on replay, let me know what you think. So Samuel's already come through and said, yeah, forklift. Let's just wait for that to come through to, there we go. Yeah, or a tiny robot arm attached. Ooh, I like the idea of a tiny robot arm. You modify the version 4 to have an FPV and servos. Ooh, yeah, that would be awesome. So I did go on to Cult 3D and download these mods. So I've purchased them from Kev Thomas. He did give me a free SMARS version 4, actually, the original one when he came out, as a sort of thank you for doing some of these, not promotional videos, but community videos for the SMARS community. So I have got the original SMARS 4 anyway, and I think that's going to be on my bucket list to do that. So forklift sounds amazing. I'm very interested in that tiny robot arm. So if you've got a design for that, I would be very interested. And the FPV as well. I've not played with any of those yet. I do have a drone. I was thinking about FPV and the sort of, the goggles that you can wear, all that kind of stuff. So that would be quite cool to play with. So what does everybody else think? Chip into the comments if you're watching on replay, and next week I'll tell you what the result of that is. So I think that's quite an interesting thing for us to look at. So for next week's video, that'll be all about loading the code. So I can show you this follow me code that I've created this week. We can go through what that does. And it's very simple from a programming point of view, because it only goes backwards and forwards, and it's just detecting a distance as well. So it's very simple for us to do that, and we can do that as an example of how to load things from the Arduino IDE into our SMARS. That'll probably be quite a short video for us, that one. So yeah, that's what we'll be looking at next week if you're following along. So that's the slides done. So let me just have a quick look and see what else we had on my show notes there. So we talked about that. So yes, so when I look through every week at the stats about who's watching, I always see that about half the people that watch this are not subscribed. So if you've watched this far and you haven't subscribed, please like, subscribe and tick the little bell. Really helps me along, and helps the YouTube algorithm pick up the content and share it wider, so that we get more people building SMARS and building robots. I'm interested in all robots, not just SMARS, but this series has obviously been focused on SMARS. I want to go as far as we can with this, do as much as we can possibly think of with this format, this platform, because I think it's so accessible. So many people can pick this up. Schools, I get contacted quite a lot on by email via my website from a lot of educators who say, can we use the materials that you put on the website for their classes? Absolutely, 1,000,000% yes, please do. And please give me feedback as well if there's something missing, or there's something you'd like to elaborate on, or you have something to share that you want to put on the website. Let me know. We can make that happen very easily. And you'll notice on the website there isn't any advertising or any kind of hard sell of things. You can buy things from the site if you wish. I've curated these components that you can see here. A lot of these components you can buy through the site, but I'm certainly not doing a hard sell on that. It's just more for convenience for you guys to find the right parts and know that you're getting it from sort of a trusted source. So yes, let me know what you think about what we should be working on next. And let's see what we can take this thing. Let's see what else we can do. I can't wait to get into some of the more complicated chips like these ESP32 type chips, because these are 32-bit and means we've got more room to breathe. We have more memory. We can create much more complicated programs, and we can do things like visual and computer vision. There's a whole CV library in Python that I'm waiting to sort of, doing evil fingers, I can't wait to sort of play with. So just before we go, there was some other things I was just going to talk about. So I was talking about DuPont connectors before. I'm just going to move this before this is going to go mad. There we go. I'm going to have to unplug in. There we go. So I bought one of these kits. So this is DuPont connectors. So I don't know if you can see in there. I'll just open this thing up. So we have all the different types of headers in there, and we have these metal things as well, which we put into some it's like a special this device. You sort of put the connector in there and you crunch it, and it pushes the things into place and crimps it down. Now, this wasn't expensive, but I believe to make this really work, you need to spend a lot of money, like over $100, under £100 on one of these types of things to make this really work. I didn't find these worked very well at all when I was creating my own DuPont connectors, and it's just a wire. You just crimp in one of these small pieces of metal into the, get that to focus there. Go on, focus, focus, focus. There we go. Basically just tear off one of these. You get one of these little black connectors, and they're quite nice because they're pre-formed. See if it'll focus on that. That's one with 4. And there's a whole different range of them, every configuration you can imagine in this little box. So I was quite disappointed when I found that these didn't work very well. They would basically just pull out. And I was using the crimper, there's not much to it really. You put the wire in, you press down, you click until it crunches, and then that's it. So I found that these didn't work very well for me, so I just buy my DuPont connectors already pre-wired. I'm just looking around again for that batch of them. So you tend to get them in like a huge strip. They start out, you know, like looks like an old printer cable, like quite wide. So there's that many on, and you sort of tear them off as you need them. But they've got the connectors already, you know, pre-molded on the end. So a bit disappointed that this didn't work. And the other thing I've got here I wanted to share with you as well, just for some future projects that we can work on with our SMARS. Oops. So I've found this, which is a wireless charger. So what you do, there's a pair of these, and they're just like a tuned circuit really. So let's get that. So each of them have got like a little circuit on the end, but basically when they're very close together like that, induction means that you know, there's a magnetic field that goes around it and power is transferred from one to the other. So it's just a wireless charger. So we could combine this with a battery, like a LiPo battery, inside the bottom of our SMARS, and it means when it's over like a little home area, it could charge up, and it would mean we can do away with the 9-volt batteries, which you kind of go through them quite a bit if you're building SMARS a lot. I also came across these, which were an interesting find. So they're a little keypad, very, very thin, but it's an alphanumeric keypad, and it just has some DuPont connectors on the end as well. So we can wire this in, we can detect, I guess it uses like a matrix, so it has 4 and 4, and it can figure out which of the 16 buttons you press by scanning up and down, as like so. Usually use like a bit shift chip to do the scanning, or so you don't have to have 16 pins. It might have something in there, but anyway, got loads of them. So I thought maybe we could do something with that. I was thinking maybe like a big track, if you know what a big track is from the 80s. Yeah, I always wanted one of them. And then the other thing I found was these things. So these are soil detectors, or they're like a little. Let's get it out so you can see it. So there's like a little stabby thing with 2 pins on the end, and you know that goes into the soil, and you can measure the essentially the resistivity of the soil. So it just measures the the resistance between the 2 pins, and it can work out from that whether the soil is moist or not moist. So and there's just a little. Looks like a buck converter. That it's just some chip and some pins with it, but yeah, I thought maybe that would be an interesting little project to try. And there is one on the SMARS Thingiverse page that Kevin created that has got something like that little prong thing. So got a whole bag of them as well. So I usually look around some of these websites to see what they're selling, and I always think that'll do for a nice project at some point. So I think that's everything for my table of goodness this week. My little puppy got hold of this screwdriver and decided to chew the end of it, so it's all mangled. And I, of course, rocking the brand new Apple Watch as well. Humble brag. That was talking midway through the video before. Okay, so I think I'm rambling on a little bit here now. So recap: we've assembled our SMARS last week. We've wired up all the electronics, and we've got a little piece of code that we're going to look at next week, which will test out the rangefinder and the motors to make sure that it's all working properly. And we had a little play there with some of the pins just to make sure they're in the right orientation, and that's because this follow me code, I know what it does and I know what behavior it should have. So if I go back to the overhead camera at the moment, these are still live. So if I put my hand there, it'll jump backwards. If I do the same on that one, it'll reverse back. And if we get them in a little line, I think they'll follow each other. There's no left or right though, so they do jitter about a bit. So if I go to the front for this one, and get it to go back. There we go. Kind of works. So what I was thinking was have like a remote control, a Bluetooth control SMARS at the front and at the back. Them Caterpillar tracks really are quite powerful. Yeah, so I was going to have a remote control Bluetooth one at the very front, and then behind they would all just be running that standard follow me code, and they would all sort of follow together along. So I've currently got 6 SMARS. You can see them all there. Stop. And I've got quite a few other parts of SMARS that have not been built yet. These are the wheeled ones. So if I go back to the overhead there, you can see 1, 2, 3, 4, 5, 6. We have some chassis and some, you know, not quite built yet parts. And I do have 2 quad SMARS as well. So let me know again in the comments on replay or live whether you think we should build the quad next or whether we should build the forklift. I think we might build the forklift, sorry. And we shall see where that takes us. So there's just one more comment there from Samo, which if I just bring that on screen. So you've also got the Mecanum wheel version in production. Can we collaborate? Absolutely, we can collaborate. Just drop me a Facebook Messenger message, or how else you can email me on kevinmcaleer@gmail.com as well. I look through that regularly. Yeah, let me know what you want to work on, and we can definitely work something together. I think that would be awesome. So that's the cool thing about having quite a small community like this. We can absolutely do things like this. This is not a problem. It might be different when we have millions of subscribers, but I think I'm way off that yet. In fact, I noticed my subscriber count decreased by about 3 subscribers in this past week. So I clearly have said something, or maybe Facebook's analytics are not quite working. Who knows? Anyway, I only want people who are really passionate about robots following me, so it doesn't bother me too much. This isn't a vanity thing. Cool. Well, thanks for watching along. Next week we'll be looking at loading the code and maybe some other things as well. And yeah, that'll be nearly the end of this particular series. So let's get some little bonus videos done on things like the forklift and what else did we say? The version 4 as well. That'll be quite cool. So thanks for watching, everybody. Again, remember to like, subscribe, and tick the little bell. And we didn't have any comments, so I can't do a comment of the week this week, so make sure you comment on the replay. As soon as I've ended this video, you can actually go and find it on my channel, just youtube.com/KevinMcAleer28, and you can find the video in there, and you can just do a comment. So if you want to be featured as the commenter of the week, I was actually considering doing a giveaway as well, maybe giving away one of these SMARS. Giving away one of maybe the best built one that I've done so far, which is probably this one here, which has got the it's just the nicest printed one so far. Got the printer dialed in the best, so I was looking at getting all the best parts together and maybe doing that as a giveaway to kind of encourage a bit more engagement with people too. So let me know what you think about that too. And yeah, I think we'll draw it to a close there then, and I'll speak to you all next week. So see you all then. So what I should always say at the end of my videos is keep building robots, keep bringing them to life with code, and keep having a load of fun along the way. Thanks for watching, everybody. See you next time.
I try so hard to fade away, but something's forcing me to stay. It'd be easier for me